Hi, how are you? Mr. Halpern here. Sorry about that. We are going to be doing some practice with those molar relationships, which was that last problem at the bottom. So if you need a little bit more practice with that, which I think we will, it's okay. Um, we're going to do here. So we're going to use the equation at the top, and we're going to ask several questions below, just breaking it down slowly, okay, so we can see the process, all right? So, number one, find the molar mass of each reactant specified in the equation, all right? So, there are two reactants, right? Copper oxide and hydrochloric acid, all right? So, what do? Step one, all right? Molar mass. When we're talking about molar mass, we need to have our periodic table of elements. Again, we love it. We love it. Okay? So have it out. I have it right here. All right? Always have it handy. Always have it handy. Okay. So, copper oxide, copper and oxygen, right? You put that together, right? Copper oxide is 79.54 grams per mole. All right? Hydrochloric acid, all right, is 36.46 grams. All right? Let's do the products too while we're at it. All right? Copper chloride is 134.45 and water is 18.02. Okay? Don't worry too much if you don't have the hundredths placed down correctly. I'm really more looking for the tenths place, right? Again, the way we do this is by breaking each individual reactant and product down into the individual elements, right? And how many there are, okay? And each element has their own molar mass. It's on here, okay? That's the decimal on there, okay? And we use that to add all the molar masses to get the individual molar mass of the reactant or product that we're talking about. Okay? So, number two, we need to find the mass in grams of each of the following substances. A, 1 mole of hydrochloric acid. All right? 1 mole of hydrochloric acid. Well, if we have the molar mass of hydrochloric acid, right, which we do, hydrochloric acid, right, we have, let me take a look, pop, 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 pop. Hydrochloric acid is 36.46 grams per mole, right? That's the molar mass. Therefore, right, roughly 36 grams. Okay, they rounded it, right? So, by the way, I said they, right? These are some of the problems that are from the book. So if you need a little bit more explanation, I suggest going to the ChemCom book for some more examples and, different ways of breaking it down. Okay? What if we had 5 moles of hydrochloric acid? What would we do to the 36 to get 5 moles? Because 36 is just 1 mole of hydrochloric. All right? Think about it. If you said multiply by 5, that's correct, right? And we use a conversion factor. Notice, 36.46, right, grams of hydrochloric acid, right, is in every mole. All right? So when we have that, we can cross out moles, and what are we left with? Grams, right? Which is what we want. We want the mass. Perfect. Okay? And the answer is 180 grams of hydrochloric acid is 5 moles. Right? What if we had 0.5 moles of copper oxide? What would that be? All right? Well, if we know that 1 mole is 79.54 grams, then 0.5 would be, what would we do? half. Let's see if that's right. And it is. All right, so roughly speaking, 40 grams of copper oxide is 0.5 moles of copper oxide. Okay? Again, we're using a converting factor, but this time, all right, we're crossing it out. We have, again, we want to go to moles, so, we want to go to grams, so we want to leave grams, and that's what we have, and our answer is 40. Okay? For the time being, do not worry about significant figures. Number 3, all right, find the number of moles of substances that are represented by 941 grams of copper chloride. Now, how do we do that? How do we convert from grams to moles, right? We convert with a conversion factor, all right? What's the conversion factor for copper chloride? Well, copper chloride, right, 1 mole of it, we just found out. Let me look up there for a second. 1 mole of copper chloride is 134.45 grams. Okay? We have 941.5 grams. Whoa, it's a lot. Right? So it's definitely going to be more than 1 mole. All right? So let's see. If we take this number, all right, and we divide by 134.45 grams, what we're doing is getting rid of grams, and we're left with moles, which is exactly what we want. And we have 7 moles of copper chloride, and that's the answer, 7 moles. Okay? What if we have 201.6 grams of copper chloride? Well, that's still more than a mole, right? A mole is 134.45 grams, but it's not much more than a mole, right? So I'm guessing somewhere in between 1 and 2 moles. Let's see if that's right. All right. Oh, it's exactly between 1 and 2 moles. All right. What we do again is we take 201.6 grams, the grams, and you divide the grams by the converting factor, which is 134.45 grams, right, for every mole of copper chloride. So again, we can cross out grams, right, because they cancel out, and we're left with moles, and the answer is 1.5 moles of copper chloride. Okay? How about 73 grams of hydrochloric acid? What do you think? Well, we take a look at 73 grams, right? Multiply it by a conversion factor. For every 1 mole of hydrochloric acid, we have 36.46 grams of hydrochloric acid. Again, we can cross out grams, all right? And what are we left with? Moles. So lovely, so lovely. And we have 2 moles of hydrochloric acid there, right? Number 4, how many moles of copper oxide are needed to react with 4 moles of hydrochloric acid? Okay, well, if we have 4 moles of hydrochloric acid, right, and in the equation we have 2 moles here, okay, and what do we say? Well, if we have 4 moles, and for every 1 mole of copper oxide, you need 2 moles of hydrochloric acid, then we need 2 moles of copper oxide. All right? How many moles of hydrochloric acid are needed to react with 4 moles of copper oxide? Well, for every 2 moles of hydrochloric acid, I know we have 1 mole, we need 1 mole of copper oxide, right? So that means that we would need 8 moles of hydrochloric acid. Okay? So these are some practice problems. If we went too fast, go back, rewind, all right? And look at it again, okay? Go through the process again. Bye.